So for this problem, we have another problem regarding addition of vectors. It's similar to the previous one. Number 5, a soccer player running forward at 7 meters per second kicks a soccer ball with a velocity of 10 meters per second at an angle of 10 degrees with the horizontal. What is the speed of the kick? So I'll take this away. Okay. Let's head straight to solving. So basically, when it comes to these ones, of course, always and always represented in the Cartesian coordinate plane. Illustrations are very important. So north, west, east, south. Never forget your, cardinal directions. So it's running. The soccer player is running forward 7 meters per second. So basically, it represents the 7 meters per second here. And he kicks the soccer ball with a velocity of 10 meters per second at an angle 10 degrees with the horizontal. So there's another keyword, with the horizontal. So when we say with the horizontal, it's always going to be, basically, this is the horizontal line, this is the angle, Basically, that's how we're going to represent the illustration when it says with the horizontal. This will be the vector itself with the horizontal, meaning it starts from here, the horizontal line, up to here of the vector itself. So now 10 degrees with the horizontal. So now represented like that, 10 meters per second, 10 degrees. Now we're going to be using two methods like we did in the previous example. First is the law of cosines, which is a much shorter method on finding the resultant vector. So let's extract this here. So now we have 10 degrees, 7. Let's try it as a 7 first, since we're going to be solving anyway. Just keep in mind that to never forget the units by the end of the problem. So when it comes to vectors, again, when it comes to translating vectors, let's say these are to do vectors and they're connected, something like that. As you can see here, it's connected something like that. We can translate the vectors like this, but never have the bottom of the arrows touch each other. Never. It's always gonna be like that, when translating, or like that when translating, of course. So since we have it translated, it's gonna be like that, 10, 7, and 10 degrees here, 10 degrees. So basically, we're gonna find the angle here, angle theta. Since this entire straight angle here, again, straight line, it results in a straight angle. Adding these two up, theta plus 10 degrees, should be 180. I said the answer, but yeah. So what's gonna be the angle? Yeah, of course it's gonna be 170. So 170 degrees equals theta. Let's name that here, 170 degrees. And our resultant vector using the tip to tail method here, that's gonna be our resultant vector, or what we're gonna be finding using the law of cosines. Now the law of cosines, to reiterate, is c squared equals a squared plus b squared minus 2ab cosine theta. Now c would always be the resultant vector here. That's our unknown. A squared, or a, would be the length of the triangle here that is larger than the other one. Since 10 is larger than 7, which one here is a? Obviously 10 is larger than 7, so this would be a, right? Yeah, it's gonna be a. So 10 here, and the smaller one would be 7 squared. And we use that here at the 2ab part as well. So 2, 10, 7. Cosine theta. Theta would be the angle that we solved a while ago for the triangle, which is 170 degrees. 170 degrees. So now we're gonna have to isolate c. So square root both sides. It will be c is equal to square root of 10 squared plus 7 squared minus 2, 10, 7 cosine 170 degrees. and substituting that into the formula into the calculator would be 10 squared plus 7 squared minus 2 comma 10 7 cosine 170 would be 16.9373 16.9373 meters per second. That would be the resultant vector of this problem here. A soccer player running forward at 7 meters per second kicks a soccer ball with the velocity of 10 meters per second at an angle of 10 degrees with the horizontal. So now to check this problem, we're going to be using the traditional analytical method way of solving. Again, we use the Cartesian coordinate plane here, and now we basically just represent them into individual Cartesian coordinate planes. Now you might be wondering, why are we representing them into separate Cartesian coordinate planes? Now basically think about it as vectors, we're just trying to find the lengths and the lengths, opposite and adjacent sides of the right triangle. So just separate it. It's easier, okay? Northwest, east, south. It's easier to do as well. So basically we have 7 here, 7 meters per second, 10 meters per second at an angle of 10 degrees, the horizontal line. So now let's use the analytical method again. So 7 meters per second east, we don't really have to solve anything since 7 meters per second to the east already. So the x-axis is 7, there's no height, he's running, so 7 comma 0 would be the component form of the vector rather. So however, for this one, we're gonna have to use the formula. So 10 degrees is already the angle starting from the east the east part of the x-axis up to the resultant. So we basically just substitute it into the formula. So for the x component, it would be the magnitude 10 cosine 10 degrees, and now 10 sine 10 degrees. Let's substitute that. 9.8481. Yeah, let's do that. 10 sine 10. So when it comes to rounding off, I actually have a hard time for rounding off. It's like when it comes to the long decimal numbers, when it comes to the test especially, I have a hard time with decimals. Not exactly calculating with decimals, no, but rounding them off. So what I do is I just use the entire number while solving and then just round it off by the end of the problem. I don't know, I just want to say it. And this would be the component form of our vector. Now these are the lengths, okay? Just remember this concept. What we found are the opposite and adjacent sides. Opposite and adjacent sides, what are they? Parts of a right triangle. In the parts of a right triangle, there are always just straight lines like that. Straight lines like that. And if we remember the concept of parallel and anti-parallel vectors, is that parallel vectors, we add them up. Anti-parallel vectors, we do add them up. However, one of the they're opposite, they're going to the opposite direction. They have opposite signs. So basically, if we add them up, it's gonna result in it's gonna be positive plus a negative. That's it. That's pretty much it. So now these are x components here. X here, x here. If we add both of them up, we can add both of them up because they are both x components. Remember, so 7 plus 9.8481 is equal to plus 9.8481 16.8481. Now adding the this is 0, so just copy it. 1.7365. I'm just gonna write here so that it's gonna be organized. So now Our final vector component form is 716.841, 1.7365. Okay, now substitute it into the Pythagorean theorem. 16.8481. Substituting that into the formula would now be 1.7365, 16.937, 16.735. And as we can see, with the law of cosines method, it had the same answer. 97, I mean for this one 97.3. Because but it's the same. So there's a shorter method using the law of cosines, as well as the analytical method here, in which we can use as well. Thank you for watching.